Welcome to physics lesson, and the topic for today is linear motion. We are continuing from where we stopped yesterday. It is 5:13. We are starting at exactly 5:20. So get ready, have your calculator, have your notebook where you are going to write the short notes. Thank you. So it's now time. I hear it said 5:20. It is 5:20, and so we can start our lesson. So first of all, I always say you are highly invited to Ambassador Speaks YouTube channel, where we study physics, we study chemistry, we study general life, knowledge in life, where we can even talk about academic excellence and very many things. So don't fear to check on the very many videos which are on our YouTube channel. I also request the followers on Shifting Grades International School to follow Ambassador Speaks, and I ask the members in Ambassador Speaks to follow or subscribe to Shifting Grades. So we are doing it, or we are working it together. So I welcome you, and confirm that you can hear me from where you are. Let me just know whether you can hear me. Yes or no? Okay, so and tell me where you're watching me from. Today, I want us to talk about linear motion. Like I said yesterday, we have several types of motions which we are going to consider. Now, today, I'm going to focus on the three equations of linear motion. Actually, the three equations carries the big So let's look at this. Now, these equations, how are we supposed to use these equations? We use these equations depending on the question you have been asked. V stands for the final velocity. U stands for the initial velocity. A stands for the acceleration, and T stands for the time. So if you have been asked to calculate V, and in your V, you're told to calculate V, and you have U, you have A, and then you have T. Then you can use the first equation. If you have been told to calculate V, and you don't have T, you have maybe S, A, and U, then you will not work with the first equation. You will work with the the third equation. Of course, some questions will be in such a way that you can even use more than one equations here. Some questions have enough values that you can use more than one equation. Like you are supposed to calculate for S. So you can either use the second or the third when all the other values are available for you to do the calculation. Now, also, these three equations, we apply them when a body is moving in a linear motion on a smooth surface. That is a frictionless surface. Because when we include friction, then the friction may be acting as the factor that decelerates the moving body. These ones, we are going to have 2 or 3 examples on the same. Then we see how they are supposed to be done. Then from there, we use the 3 equations again when we are discussing, or when we shall be discussing, motions under gravity. Like objects that move as a result or under the influence of gravity. That is the first thing I would like you to know. So allow me to give you one question. Like I can give you a question right now, then we do it together. You tell me whether you have understood on how to operate with this. So of course, some questions would be like, derive. So I'm now leaving this as a assignment to you. Go back to your notes. Learn how to derive the first equation, the second equation, and the third equation. From the third equation, there are two ways you can derive it. So in physics, we call it derivation question. Derivation question. But of course, in an exam, you will just, an examiner can tell you, show that V is equals to U plus AT. Now this person is telling you, how did we end up coming up with this particular formula? So you are supposed to derive, showing steps properly. Don't write your own things. Then therefore, hence, then you just write the formula from nowhere. No, we must follow the steps that yield or produce this particular formula. That's your assignment as a good student. So please ensure you do it in the best way possible. Now, listen to this question. A car starts from rest. A car starts from rest. Already there is something you have. There is information you have been given, this one. It starts from rest with uniform acceleration. With uniform acceleration of 5 meters per second square. We have something here. How long does it take? How long does it take to cover a distance of 400 meters? Good. How long? So first of all, when you are told how long, we are looking for t. That is the time. Now, let's discuss this question in this manner. Yes, I'm checking what there are some of you who have joined and commented so that I can recognize them. Now, here we need to ask ourselves: a car starts from rest. What does that mean? The initial velocity is 0. The initial velocity. Just a minute, I'm checking on something here. Yes, it means now the initial velocity is 0. So our u is equals to 0 meters per second. Let's continue with the question. With uniform acceleration of 5 meters per second. So we have A, which is 5 meters per second square. How long? Now t. How long? T. Yeah, Tuna, how long does it take to cover a distance? S. 400 meters. I know somebody is like, we know S is for displacement. S is for displacement. Now, how are you saying again that S is distance? Yeah, at the beginning of the lesson or topic yesterday, we said that the distance, displacement are two different things. But now, where we are, the distance, especially when we were doing this, distance and displacement, all of them are covered by S. Yeah. So, look at this. Which equation are we going to use? UATS. Confirm with the available equations over there. Which one are we going to use? Can we use the first one? The first one, I thought the idea, okay, we want to calculate t. if we try to use the third one, first of all, we rule out the third one because aina mahali pa t. And we are supposed to calculate time. The second one, it has t, it has u, and it has a. So we can use the second one. What about the first one? The first one has a place for v. That is the final velocity. And we don't have a final velocity here from our question. So we will say S is equals to ut plus half at squared. Now, S is 400 meters. Is equals to ut 0 times t 0t. So itakuwa 0 plus half times a, which is 5. This is 5 times t squared. Yeah. So our t squared, now let's do mathematics here. 400 is equals to half 5t squared. 400 is equals to 2.5 t squared. (2.5) t squared is equals to 400. So I have to find out t squared ni ngapi. I don't have a calculator. But I can just find it out here. Yes, 400 divided by 2.5, we get 160. 160. Then, of course, square root of 160, you will get the value of t. I hope up to that point I'm very clear. That is the question. So I was just doing this one question so that you can know that for you, before you choose on the equation to work with, then you must have seen the available values. I hope I'm clear up to that particular point. Yeah. Now I can check on another question. Then now we proceed. I talk about the motions under gravity. So I want to go to the second question. I may not do very many examples because of time, but of course I expect you to go and do more examples. Yeah. The second one wants us to calculate the distance. The question reads, a body is uniformly accelerated from rest to a final velocity of to final velocity of 100 meters per second in 10 seconds. In 10 seconds. Calculate the distance covered. Calculate the distance covered. Calculate the distance covered. So let's look at the question. A body is uniformly accelerated from rest. So hapo kwanza wewe jua tu the initial velocity is equals to 0 meters per second. To a final velocity of now v 100 meters per second that is in 10 seconds. Now t is here in 10 seconds. Calculate the distance covered. Now we are supposed to look for s. Now from our three equations there, we can ask ourselves a question. Look for an equation that has u, v, t, and of course s. Ondoa ya kwanza. Ya pili, if we use the second one, ut. Do we have ut? Yes. Plus half at squared. That one can still work out very well because we can get the acceleration, because acceleration is this minus this over this. We can still get the acceleration over there. What about the other two? V squared is equals to u squared plus 2as. So in this case, we can use either the second or the third equation. Let's use the second equation, that s is equals to ut plus half at squared. S, we don't have, equals to u, 0 times t. Hapa itakuwa 0 plus half times a. Now ask yourself, where is a coming from? A, aja nifanyia hapa, ndafuta a is equals to v minus u over t. V, 100 minus 0 over 10. So our a is going to be 10 meters per second square. But of course, when doing the exam or the question, let the teacher know that you had actually calculated a. If workings iweka hapa, mimi nimeweka pale because of the space, na kuna venye ikiteremka chini sana hautaiona. Aya. I'm forced to take this one down here. Yes, so today you have not told me where you are watching me from. Leo mmenyamaza kwa nini? I would like to know where you are watching me from. Yes, so this question now will land you to half times 10 times 10 squared. So 10 squared is 100 times 10, 1000 times half gives you 500 meters. We will do the last question, but before that, let me check what the shifting grades are saying on the other side. So if you're watching me from the shifting grade side, I would like to know what is your comment. Where are you watching me from? Then, of course, the lesson will proceed very well. Leo hamtaki kuongea, sijui mko na shida gani ama mko na njaa? I want us to do the last question, then I explain something. Other calculations we will do it tomorrow. Na yeye aliachanga physics zamani. So venye nilieleza introduction ya linear motion, nikaanza na the terms, then akasema kumbe niliacha physics pure na ni rahisi, na aliacha akiwa form 2. So wewe mwenye unafanya physics, you read the right thing. A body whose initial velocity is 30 meters per second moves with a constant retardation of 3 meters per second square. Calculate the time taken for the body to come to rest. Haya, hiyo sasa nilikuwa naandika tukiongea. Sasa nataka tusome na wewe pole. We do what we call unpacking of the question. Read to understand the question. What is there to be used to answer the question? Now, a body whose initial velocity is 30 meters per second. This one has not started from rest. We started dealing with that body when the u, which is the initial velocity, is 30 meters per second, moves with a constant retardation of 3 meters per second square. Now, in our case, we will not work, from our equations there, we don't have retardation, but we have the opposite of retardation, which is acceleration. Now, I will use the word a, but nikifika kwa the actual retardation, I will use negative 3 meters per second square. Whenever you're told that the acceleration is negative 3 meters per second square, just know that the retardation is 3 meters per second square, or the other name that can be used in place of retardation is deceleration. Yeah. Calculate the time taken. Now t. Calculate the time taken for the body to come to rest. Meaning, the final velocity to be 0 meters per second. That is the point. Okay, so in this case, we have how many equations? We have the first one, because v is equals to u plus at. In fact, it's as simple as that. We are looking for the first equations of the linear motion, which is v. Just write the equation first. U plus at. I hope it is visible. Can someone confirm that you can check what I'm writing? I'm trying to check. Okay, just confirm that you can see what I'm writing. V is equals to u plus at. So, in fact, kuna mtu mwenye ataanza equation as anaandika hapo solution from the first equation of linear motion. Then write this. You write this first. The available values to be used. Then, as you say, from the first equation, v is equals to u plus at. Then v, which is 0, is equivalent to u, which is 30, plus at, 3 times what? T. Chukua hii kuje is which one now are we supposed? We are supposed to calculate what? Time. Now, kumbuka, our a is negative, so you will have to place negative there. So it's going to be like 0 equals to 30 minus 3t. Now take this, ikuje huku. 3t is equals to 30. Then our t is equals to 10. Now then write seconds, because umefika mwisho. Yes. Hii swali ni ngumu kweli. Can you see what I'm writing on the board? Kwani hawa wenye kinaongea na wao ni akina nani? Hawataki kunijibu. Wacha niangalie kwa shifting grades. Hao ndio wanaongeanga. Kuna wengine hapa wa ambassador. Hey. Ambassador sijuangi shida hao inakuanga gani? Hey, hata shifting grades wako na mchezo siku hizi. Anyway, there's no problem with that. So, now let me explain something here. Motion under gravity. Of course, I've just done for you 3 questions. You can still go and do more and more and more. Do much practice. And of course, it's going to be perfect. There are 3 motions under gravity. Then kuandikia hapa motions under gravity. By the way, kuna kitu inafaa mu appreciate. I have the best handwriting ever. This one I've never seen anyone having such a very good handwriting. So we have 3 motions under gravity, which we can be checking on. One is free fall. What's the time? 5:49. Oh, we still have 20 minutes. Free fall. 2, upward stroke vertical projection. Then number 3, we have horizontal projection. Yes, these 3 are the ones that we call them motions under gravity. So these bodies, they move under the influence of either the force being projected, but again it's going to be influenced by the gravity. What does that mean? Wacha nianze na free fall and then upward vertical projection. That's combined. If I throw this pen upwards, it will go na irudi chini. If I let this pen drop, I'm not drawing it, I'm letting it drop. Like naachilia situpi hivi, naachilia tu iende hivi. Now tuanze na hii ya kuachilia. Naachilia when the initial velocity is 0. But by the time imekonga mkono yangu, inakonga mkono ikiwa na a higher velocity, not 0. Yet hapa niliachilia ikiwa na ngapi? 0. So as the object is falling down freely, there is an increase in velocity with time. Nikitupa hii juu hivi, na natupa because I have to force it with some energy and force. I project it with force. Like it will be leaving my hand with a velocity like maybe, for example, I can mention a velocity like 20 meters per second. Imetoka imeenda hivi. Lakini after some time, imeenda mpaka juu na imeanza kurudi chini. So let's ask ourselves. Mbona nikiproject inaenda ikireduce velocity, lakini nikiachilia iende chini inaenda increase nini? Velocity. The reason is because there is what we call gravity. Gravity in this case moves towards the center of the earth. And therefore, if an object is going against the gravity, like the object you are throwing it upwards, it's going against the gravity. The gravity will be pulling it where? Downwards. It is the gravity that is responsible for the retardation or the deceleration of that object you are projecting it upwards. And if you let an object to fall down freely, it is the force of gravity, it is the gravitational field strength that is pulling this object towards the center of the earth. And that's why it increases with time. I mean, the velocity increases with time. Ilianza na 0, lakini kitambo ikonga pale chini, inakwanga imekonga na a given velocity. Why? It was moving in the same direction as the force of gravity. Are we together? Now, tuanzie hapa. Nikitupa hivi inaenda ikidecelerate. Nikiachilia hivi inaenda accelerate. Kwanza achana na horizontal projection. Kwanza nataka tumalizane na hizo mbili kwanza. I want to combine. I want to bring these equations to fit these two. Nataka nianze na free fall. In free fall, first of all, one thing that we need to start first of all is that in this case, the acceleration is provided by the force of gravity. So where we have A, we use G for a free fall. And because the gravity is working for the object to move very fast, then I'm not changing anything else. So I will just have this, V is equals to U plus GT. I will have S is equals to UT plus half GT squared. Ya mwisho, I will have V squared is equals to U squared plus 2GS. Where we have A, nimeweka nini? G. That is for an object falling down freely. Yes. Aya, ndaka tuingie kitu ingine. Ndaka niingie kitu ingine. Hello. Yes. Wapi? Niko kwa lesson, but let me send Brian angalia. Brian? Hapa nimeona mtu amenitext hiyo kitu ananiambia Kikuyu imefungwa. Hebu wacha ni sawa. Haya. Brian. Kuja. Hebu su confirm hapo nje kama kuna curfew, like uone kama nani anaweza toka huko kuja hivi. Hiyo dirisha imefungwa ni frosted eh? Aya, kuja tu uangalie hii side nyingine alafu uniambie. Sorry for that. Ni maneno tu ya Kikuyu, kuna curfew, like watu hawataki kukubali ya kwamba Ruto ndio president, wanaleta maneno mingi mingi. Msianze kusema ati unfollow nani enda tumbaka pale, lakini usiingie barabara, like check tu from hapo na ukuje uniambie. Yeah. So that is for the free fall. Now, let's consider an object that is being thrown upwards, vertical projection. That object, it goes upwards while its velocity is decreasing. Why? It is going against the force of gravity, or some people would call it gravitational field strength. We anasema nini? Uba Ugolo. How are you, mwalimu? I'm very fine. Why are you watching me from Uba? Tell me. Sawa. Now, if an object is going upwards, then the gravity, which is the acceleration, in this case, is negative because it is decelerating. So if it is moving upwards, then hapa itaweka negative. Hapa, I will put a negative. Moving upwards with. Moving upwards against the force of gravity. It will change. G will still be there. But now, I would use the word negative. Yes. All this, just calculate it. You will get it. There's no problem with that. Aya. Nataka tu nieleze kitu moja alafu we end the lesson. Kuna watu inafaa ni waokolee mahali. Wameshikiwa mahali fulani kwa jam. I have to go and rescue them. Now, let's talk about kitu inaitwa horizontal projection. Horizontal projection. Like, look, uko juu ya meza. Hii mpira imekuwa kicked imeenda hivi. This ball will never move horizontally forever. Hata hii imeenda chini sana. Itanisumbua kuchora hiyo curve. This object will move this way while landing down hivi. Haya, I want you to listen to me very well. Kuna kitu hapa nataka niseme, and maybe you've never heard of it. About this. We have this height hapa, which is given by half gt squared. We have this from here up to here. It is the distance, which is not known as the range. Range, which is r, is given by ut. I'm not going to do any calculation question, but I'm just explaining first. Now, upper, if you're told to calculate how far it moved from the bottom of the building, it is initial velocity times time. Height is given by half gt squared, like how long it takes, then use g. Sometimes you are given t, then you have to look for the h, and you will get it. Iko sawa? Magari zinapita? Kuna kafi za ngapi? Hakuna kukuja tu. Bado but itafungwa tu. Karakisha, uko wapi? Aya, sawa. So, now in this case, you will be given some information, like you may be given u or you may be given t. When you are given t without u, then you have to apply this to, or you may have the height, then apply this to get the time, because g is always 10 or 9.8 depending on the one given. If not given, use 10. After getting t, then having that t and you have u, then you can get the range. I mean, there's a way you can just operate with that. Now, what I was saying, you listen very carefully, is this. There are two types of velocities here. We have the horizontal velocity and vertical velocity. Horizontal velocity does not change. It always horizontal velocity is always equal to the initial velocity. But when the question changes and asks you to calculate vertical velocity, listen, when the question says calculate the vertical velocity, then what are you supposed to do? You treat this body as a free fall. Forget about everything else. If you're just told calculate the vertical velocity, then this body should be treated as a free fall and not horizontal projection. If you're told to find the horizontal velocity, this one doesn't need to be calculated. It is just equivalent. At any given time, horizontal velocity is the same as initial velocity. Kuna mtu anauza, is this physics or maths? It is maths in physics or physics in maths. Linear motion is always it's much of calculation. So it is physics. Linear motion. You have come late, but you can rewind the topic. Enda huko nyuma na uirudie, utapata what we have been discussing all through. In fact, you've come at a time when I'm finalizing with the lesson. So tomorrow we shall be doing the last thing about linear motion. We will be doing 2 or 3 questions. Otherwise, I wish you all the best. Thank you for joining. Subscribe to our channel, and may God continue blessing you to learn more in our channels. Have a nice evening.